Welcome class, myself Professor D.S. Rai, Professor Department of Civil Engineering, BBD ITM Lucknow. Today I will discuss course KCE 064 Foundation Engineering. Today we will cover a lecture 33 in which I will take up reinforced earth. References that I have taken here: Dr. P. C. Punamiya, Soil Mechanics and Foundation; V.N.S. Murthy, Soil Mechanics and Foundation Engineering; Alam Singh, Soil Mechanics and Foundation Engineering, and some material have been taken from internet. The content today I will cover: reinforced earth, principles, reinforced earth wall, wall facing elements, reinforcing elements, compacted earth fill, advances in reinforced earth structure, other application of soil reinforcement. The first, reinforced earth. Reinforced earth consists of a compacted soil mass within which reinforcing elements or membranes, usually in the form of a horizontal strip of metal, are embedded. So, this is the reinforced earth, means reinforcing the earth, reinforcing the soils. The friction, the first is friction developed between compacted layer of earth and reinforcing elements. The soil transfers the forces built up in earth mass to the reinforcement by means of friction. Thus, the tension is developed in the soil mass. This type of provision has been made by some scientists. The modern reinforced earth was developed by Henry Vidal in 1968. This technique is subject to patent by Vidal with reinforced earth as a patent name. The principle by which reinforced earth works. The basic principle of reinforced earth are same as design of reinforced concrete. Membrane are used to provide tensile strength in the earth mass in location where shear stress are generated. The provision of membrane lead to redistribution of stresses internally within each of the member in encapsulated layers. The reinforced soil concept is essentially based in mobilization of inner facial shearing resistance between soil and reinforcement, which is termed in restraint the lateral deformation of the soil. Why the reinforced earth required to introduce? There are many words where a space is limited or the material used are not up to certain level which could be used, especially in an urban area where there is a shortage of land. Then we can only provide the structure in such a fashion that there is no any wastage of land. So, we can make the structure in such a fashion that a very minimum or you can say optimum requirement of the land width is required. So, the reinforced earth wall consists of three components. We can see here. First is wall facing element. Where the wall facing element? This is the, in this drawing, this is the wall facing element. This is the wall facing element. We will discuss one by one. Second is reinforcing element. This is the wall facing element and this is the reinforcing element used in the structure. The third is compacted earth fill. This is the compacted earth fill above or below the reinforcing elements. We can see here by Rankine's theory, this is the Rankine's failure planes. This is the Rankine's failure plane without reinforcement, and this is the modified failure plane with reinforcement. This is the compacted fill, that this is the third component of the reinforced earth. We can see here by H by 3, this is the modified failure plane and the force will act by H by 2. Here we can see here, this is a reinforcing elements. So, this is the diagram of a reinforced earth wall. Now, come to the reinforced earth wall. First is, we have already discussed wall facing elements. It is provided at the free boundary of a reinforced earth structure to provide some form of barrier so that soil mass is contained, and this is known as a skin. It is may be flexible and stiff. It is strong enough to hold back the soil mass. It allows fastening to attach reinforcing element, because this is a wall facing. So, here fastening is attached in the wall facing elements. Usually it is a fabricated unit, and the wall facing elements are a small, light in weight, so that transportation may be done quickly and construction may be proceed speedily. So, this is all about the wall facing element. We can see this one. This is the wall facing element of this structure, which is provided on the base concrete. This is these all are small units. It can be easily transported from one place to another place, and they are light in weight, so that the construction speed may be enhanced. So, this is the wall facing element. Now, come to the reinforcing element. This is the most important part of reinforcing earth. Reinforcing elements or membrane consist of any of the following. These are the different types of reinforcing elements. The first is galvanized steel strip of 50 to 100 mm wide and up to 9 mm thick and of a several meter long and have a service life of 120 years. So, we can imagine that after the construction we can free from any type of distortion or deformation up to 120 years. The second reinforcing element is stainless steel. Next is aluminum alloys. Next is rod of metals that can be used. Then the wire grids are also used as a reinforcing element. Fiber glass strips are also used as a reinforcing element. Then the bamboos and geotextile. Bamboos are naturally available materials. It can also be used as a reinforcing element. Geotextile, a modern materials which are used for the as a reinforcing element. Now, come to the compacted earth fill. This is the third component of the reinforcing earth. Only coarse grain soil are used for the soil fill, earth fill. Not more than 10% of the particles, this is very important, not more than 10% of the particles should pass through 63 mm sieve. The third one is first layer of the reinforcing strip is placed at the ground surface. Backfilling is done with the granular soil and compacting it. The entire process of laying a strip and backfilling and compacting till the required height of the reinforcing earth wall is attained. The fill should be adequately drained to prevent it from becoming a saturated soil. So, this is the compacted earth fill. Now, come to the advantage of compacted earth fill. We can see here reinforced earth structure are quite flexible. Hence, these can withstand foundation deformation and settlement. Second, this can withstand earthquake forces more efficiently than the conventional rigid structures. It is much more economical than the conventional masonry or concrete structure. The reinforcing element can be transported easily because it is light in weight and it is small in size. So, it can be precasted at another place and transported from site of fabrication to the site of work very easily and very quickly, because the size is small and it is a light in weight. And because it is a light in weight and a small in size. So, the construction process could achieve with a very speedy rate. Reinforcement elements are easily available in various size and shape. Why it is so popular? It becomes so popular because it is easily available in different shape and size, and this can be easily stored, placed during the construction. So, these are the advantage of compacted earth fill. Now, come to the other application of soil reinforcement. Reinforced earth wall. In construction of reinforced earth wall, this is quite applicable and this can be strengthened very quickly. Bridge work. Earlier, bridge construction from the abutment and from approach of the abutment is quite difficult, because there will not be possible to compact the earth near the abutment. So, what happened during rain seasons or any seasons, when loads, traffic loads comes on the top of this area, then there is a settlement of the earth, and though there is no any remedy. After the use of reinforcing earth, this can be easily compacted and got constructed, so that this problem has been sorted out. This has been also used in construction of the dams, especially in earthen dam. Next is embankment. In embankment, when load coming on the embankment, the stresses developed in the soil mass, which creates deformation in the soil mass. If we are using reinforced soil, then this problem could be solved. In foundation, it is the use to just take care of the deformation in the foundation. It is quite applicable in highways, especially on the slopey areas. So, in the slope we can stabilize the soil by the reinforcing earth. Then the root pile system, it is also done. This is also very useful for the waterway structure. This reinforced earth is also used in underground structure. So, we will discuss one by one and other application. We can see here, this is a bridge abutment, this is the abutment. Suppose there is no reinforcing earth here. So, what happens, roller may not come up to this level. So, this portion remains uncompacted, and this creates deformation in the embankment and near the abutment. After using this reinforcing element, then the stresses developed in the soil mass which cause deformation will be borne by the reinforcing elements and transferred to the other place. So, we can see here, due to use of this reinforcing bar, the stresses developed in this area has been transferred, and so there is no deformation at the abutment point. Suppose there is a flyover. The approach of flyover is constructed because in the urban, especially in the urban area where the land is very limited. If you are going to construct a approach of flyover, then what will happen? The slope will take extra land which are not available in the, especially in the urban area. So, what we will do? We make a reinforced earth here. So, this is the facing element on both sides, and in facing, between the facing elements we provide the reinforcing element starting from the ground level, and at a certain interval we provide the reinforcing element along with the soil mass. So, in this way we get a good compacted earth fill which will not go for deformation. So, in this way this is very useful, especially for the bridge abutment and the approach of a flyover in especially urban area. Now, come to the second one, this is the embankment. If load is coming, it may be live load, it may be earthquake load. So, the soil mass, if we are not using the reinforcing steel, reinforcing members, then the soil will be overstressed and failure could be occurred. But if you are providing reinforcing elements at a different interval like this way, then the stresses will be borne by the reinforcing elements, and so the deformation could not be occurred at these areas. The load is transferred to some other areas. The next is a highway constructions. You can see here, this is the stepped highway. So, this is the wall facing element in which the reinforcing elements are fixed and earth backfill has been done or compacted. So, this will protect the deformation occurred here. So, this is also very useful for the highway construction. Here also, where there is a lack of land, then we can use this reinforcing elements, or you can say reinforcing earth. Now, come to the this is a tank we can see here, and in the tank here the reinforcing steel has been provided like this way. So, the stress developed here has been transferred. The next is this is the cutting of earth, and you can see here the reinforcing elements has been provided. This is the foundation and this is the envelope of the foundation. We can provide a reinforcing steel. So, this will bear the stress developed in the soil mass in especially zone 2nd. This is the zone 2nd. So, the stress developed, the punching failure may not occur at all. So, not only we have discussed many application of the soil reinforce, but there are many places where it has been used. So, thank you very much.